This is video number 4 on the topic motion in a straight line. So far, we have studied what is displacement, and what is distance, and velocity, and speed of a moving object. And also, we have figured out how to calculate the average value and the instantaneous value of velocity and speed. Given a trajectory, that is path of the moving object, for example, the body can move like this. So this is the positive direction of the x-axis. So given this trajectory, one can get the curve x versus t. This also we have studied previously. And velocity is defined as how fast the position is changing with time. So velocity is dx by dt, and this velocity is called instantaneous velocity, and this can be calculated for any instant of time. So one more velocity is defined, that's average velocity, which is over a time interval, delta x by delta t. Once xt curve is known, using this thing we can find velocity at any time. So that means velocity versus time graph will be known. So using this relation, one can get velocity as a function of time curve. It can be some curve like this. So similar to dx by dt, we can also define how fast the velocity is changing with time. That is dv by dt. So this dv by dt is called acceleration, which we will be studying now. And also we can also find delta v by delta t over a finite time interval. dv by dt can be defined at any time, and this is called instantaneous acceleration. And delta v by delta t is over a time interval. That's acceleration, the average value over this time interval, delta t. Timestamps are given in the description box. You can watch parts of video if you're running short of time. In this video, I will discuss how acceleration of a body is defined, how to calculate average and instantaneous value of acceleration. Finally, I will summarize this video. Consider this trajectory of a moving body. The object is at location origin at time t0, at time t1 it has moved here, t2 at the maximum x position in the positive direction, and t5 is the origin, and t6 it's on the negative side, and t8 on the positive side. This you already studied. So for this given trajectory, one can get xt curve. So for this trajectory, the xt curve will look like this. At time t0, which is the origin, at time t1 the positive side, t2 at the maximum, x value in the positive direction, t3, x value is decreased, and at time t4, x4 is same as x1, x4 is same as x1, and x5 is the origin, x6 on the negative side, x7 on the origin, x7 on the positive side greater than x1. So once you have this xt curve, one can get the velocity as dx by dt by definition, velocity is how fast the position of the object is changing. So dx by dt can be defined at any instant of time. So it's called instantaneous velocity. And this dx by dt is nothing but at the time t1, take a small time interval dt and find the corresponding increase in x, that is dx. So this ratio dx by dt is tan of this angle, which is slope of this line. And this line will touch this curve because this interval dt is very, very small. So this is a line touching these 2 points, and this second point is very, very close. So this line becomes a tangent to the curve. So velocity is nothing but slope of the tangent. So using this curve, we can get the velocity as a function of time. So this same xt curve is drawn in this figure, which is this blue curve. And using this relation velocity is dx by dt, I can get this vt curve, which is the yellow curve. So at t naught, the slope is positive. So velocity is positive. Here it's positive, but slope has increased steeper. So velocity is v1 is positive, but more than v0. After the thing decreases, and at the topmost point, the slope of the tangent is 0 because it's horizontal line. So that's why v2 is 0. And slope of the tangent at time t3 of the xt curve is negative because it's going down. So that's why the velocity is negative. x4 is also going down, negative. x5 also negative. So v5 is negative. And at time t6, the slope is horizontal. The tangent is horizontal, the slope is 0. So v6 is 0. And after that, the slope is positive. v7 is positive, and v8 is positive, but a little bit reduced. This is more steep, this is less steep. So v8 is less than v7. So at the maximum point, the tangent is horizontal. At the minimum point, the tangent is horizontal. So the slope is 0. So velocity of those 2 points v2 and v6 will be 0. So given xt curve, one can get vt curve because the relation between velocity and the displacement is derivative. So slope of the xt curve is velocity curve. So once we know the velocity curve, we can define, similar to dx by dt, we can also define dv by dt, which is rate of change of velocity, which is acceleration. So this can be defined at any time instant. So that's why it's called instantaneous time velocity, instantaneous acceleration, which is slope of the tangent to the vt curve. So here if I get the slope of this tangent here, acceleration is positive, here the acceleration is 0, here acceleration is negative, here acceleration is 0, here acceleration is positive, here acceleration is 0. So similarly, we can also define average acceleration between any 2 time instants between t1 and t3, 1 and 3. This is the from here to here, that is delta v, and the corresponding change in the time is delta t. This is for the interval 1, 3. So the acceleration over the time interval, average acceleration will be negative because delta v is negative because velocity is dropping. Delta t is always positive because we are going from left to right. So once the vt curve is known, acceleration is known. Acceleration is rate of change of velocity with time. So that is change in velocity by time. Average acceleration means change over a finite time interval delta t. That is delta y by delta t. And instantaneous acceleration is d by dt, which can be defined in any instant of time. And dt is nothing but delta t, the limit delta t tending to 0. So this is slope of the tangent of vt curve, and this is slope of the secant of vt curve between the 2 instances, 1 and 2. To summarize, acceleration is rate of change of velocity of an object, which is delta v by delta t. For a finite time interval, it becomes average acceleration in the time interval. And you can also find dv by dt at any time instant. That's called instantaneous acceleration. You can ask your doubts in the comment section.